Bismillahirrahmanirrahim and Assalamualaikum. Today I'm going to present my PSM1 session 2022-23 semester 2. I am Ni Ilhami binti Ni Ibrisam. My metric number is B20EC3013 and my title for my research is Comparison of Machine Learning Algorithm for Selecting Event Sequence Test Cases. First, in this slide, I will going to explain the introduction, the literature review, the research methodology, the research design and implementation, the result analysis and discussion. For introduction, software testing is a process to find defects and flaws in the system to ensure that it meets the specified user requirements. Software testing plays a key role in what is an increasingly complex process of developing and maintaining software products today, based on my citation of Gomez et al. 2016. Software testing can also involve test case selection, which is the process of choosing a subset of all test cases to reduce the total number of test cases, while still providing a high degree of confidence in the quality of the software being tested. Problem background. Test case selection is a technique of reducing test case suites in regression testing based on certain criteria. Redundancy in TCS is a problem that can contribute to the inefficiencies in the testing process. Redundant test cases are those that have already been covered by other test cases, therefore running them again would not contribute to the discovery of new faults. So the research aim is to investigate machine learning algorithm techniques for TCS in the context of event sequence-based test cases, and then evaluating the effectiveness of the tested algorithms. This research will compare the machine learning algorithm used, which are clustering. By conducting this research, the project seeks to contribute the ongoing efforts to improve the efficiency and the effectiveness of software testing, particularly in the context of event sequence-driven software with the implementation of machine learning algorithm. So the research question is number 1, what ML techniques are used for test case selection? And second, how to evaluate the effectiveness of TCS techniques implemented with ML algorithm. It brings to our research objective, which is to identify the most appropriate machine learning algorithm for selecting event sequence test cases, to formulate the machine learning technique for selecting event sequence test cases, and to assess the effectiveness of selected machine learning algorithm. The scope of my project would be in weighted attribute-based strategy, WAS, and execution spectrum-based sampling, ESBS, machine learning algorithms that are implemented in test case selection and its accuracy in selecting appropriate event sequence test cases. The second scope would be the effectiveness of these algorithms will be evaluated based on the ability to calculate the possibility of every test to be failure and enhance the test coverage. My research contribution would be, first is to identify the most appropriate machine learning algorithm for selecting event sequence test cases. Second is to formulate a suitable machine learning technique for selecting event sequence test cases, leveraging the strength and different algorithms and integrating them into a unified approach that maximizes fault detection rates. Number 3 would be evaluated the effectiveness of proposed machine learning algorithm for selecting event sequence test cases using failure detection ratio. Next would be literature review. There's 4 sections for my literature review. First is talk about the software testing. Software testing is a process of validating and verifying that the software product meets the requirement of its stakeholder. And there are a lot of types of software testing such as regression testing, reliability testing, performance testing, integration testing, and many more. But my focus will be on the regression testing. Next, machine learning in software testing. The discipline of software testing has seen the emergence of machine learning techniques as potent tools, opening up new possibilities for improving test efficacy and efficiency. This method can be divided into a number of categories, each having specific uses and advantage. Next, test case selection. The goal of test case selection is to choose a subset of test case from the available collection of test cases that have already been run. Test case selection is a technique under the regression test. Next would be the machine learning in test case selection. Test case selection is a critical component of software testing that seeks to choose a subset of test cases from a large test suite in order to save testing costs and time. Researchers have been investigating the use of machine learning algorithm for test case selection in recent years due to the capacity to handle massive volumes of data and complex patterns. Existing ML techniques in TCS can be divided into four, which is under the supervised learning technique, unsupervised learning, reinforced learning, and also natural language processing. My focus would be under the unsupervised, which is the clustering method. So there's two authors that I'm using their reference for my literature review. First is by Yan and other authors, which is a dynamic test cluster sampling strategy by leveraging execution spectra information. And the technique used is the execution spectra based sampling, ESBS. And next will be by Wang, is using vectored attribute to improve cluster test selection. And the technique will be used was vectored attribute based strategy, WAS. And both of these methods are using the evaluation metric of failure detection ratio and also test selection ratio. Next, the evaluation model will be based on two evaluation models, which is failure detection ratio and test selection ratio. Failure detection ratio is to detect how many failures will be found, and then test selection ratio will detect how many tests is selected. Next, we're moving on to the research methodology. There are going to be 5 phases of research in my research methodology, which is the first one is the literature review. The first step in doing this research is by conducting literature review based on related previous studies. Number 2 would be the problem formulation. From the literature review phase, the research gap and interlude were then used to identify the problem for the previous research to pave the way for problem formulation in this study. Phase 3 will be data collection and data pre-processing, which is the goal of data collecting and processing is to collect and analyze relevant information to answer the research questions or achieve the study's objectives. And then phase 4 would be experiment. In PSM1, the experiment phase will conduct an initial study using a dataset to gain understanding and experience in setting up the experiment and testing the algorithm to perform TCS. And the last phase would be the result analysis and conclusion. From the experiment conducted, the result of the selected test cases and its evaluation metric calculation will be analyzed. But in PSM1, evaluation metric will not be analyzed yet. The data source used in this research would be the event sequence-based test cases dataset program was chosen specifically for this project from benchmark sources. This program was used in this study to assess how well the ML algorithm performed when choosing test cases for regression analysis. And the example here is the CQM input test cases. Next, research design and implementation. The first one is to running the test. First, the test case will be executed to get the result of the test cases, whether it passed or failed. The results of the first execution will be used in next step of this study, where WAS algorithm will be implemented to optimize the TCS of the test cases. Number 2 will be the K-mean clustering, will be performed to classify the test cases into two clusters, T and T prime. The distance between the cluster will be calculated using Euclidean distance formula, and EI refers to whether function I is called in test T, and E prime I refers to whether function I is called in test T prime. This is in the Euclidean distance formula. And next will be assign ranking metric, which is next each function was assigned to a ranking metric, ANP, ANF, AEP, AF, which is ANP is the function that is not executed and passed, ANF the function that is not executed and the result is failed, AEP the function is executed and the test case result is passed, and AEF is the function is executed and it is failed, and the cluster is chosen to optimize TCS for the cluster. And number 4 will be from the result of the ranking metric. The function weight for each function was calculated using the formula of Jacob similarity formula, which is AEF divided by AEF plus ANF plus AEP. And lastly would be the test case selection. With the function weight value results, TCS can be performed to select test cases that are failed and need to be retested. This is the example of the first type running test. The result of pass and fails were acquired from this fault matrix calculation from a paper that I was referred to. And in this paper, I was using the same test cases program, which is the CQ input. And next will be the example of k-mean clustering. This is the first iteration of the k-mean, where we're going to calculate the Euclidean distance. Next is to assign the ranking metric. This is where we assign the ranking metric for each function based on the result of pass and fail, and also whether it's the function it is called or not in the test cases, in the test suites. Next step is the function weight calculation. Based on the ranking metric, we can now calculate the function weight calculation, which we can determine for each function their weight, which can be used in the test case selection. So from the weight that is assigned, that we know previously that the function E2 has the highest function weight. So we are going to means that the higher the function weight, the higher the test cases called the function, then it is fail result. Means we are going to exclude the function E2, which bring us to the selected test cases is now reduced from the previous run of the test cases. So for the results and analysis and discussion, an early examination was carried out to evaluate the possibility of optimizing the TCS procedure in chapter 4 of the study, and the study concentrated on the WAS algorithm technique for computing the function weight. And in cluster 2 that was chosen, 18 test cases were taken into consideration as part of the study. However, 17 of these 18 test cases underwent new testing, which means we are reducing potential decrease in the required number of test cases, since only 5% that require retesting. It is crucial to remember that the initial study had a limited scope, so it is not the accurate result yet, and it only used a dataset of 20 test cases in the early phase, which may not be enough to make a concrete choice regarding the optimal ML algorithm to be used in the TCS process. For the future work, from the initial study conducted in previous chapter, the results and its analysis will be discussed previously, and however only WAS algorithm implementations finding is available, and the ESBS algorithm will be performed in PSM2, and the evaluation and comparison between two algorithms also will be discussed in PSM2, and further research will be continued in PSM2 with implementation of WAS and ESBS algorithm to select event sequence test cases. So that's all from me. Thank you.